In this video, we are going to see about the stack linked list implementation. Okay, so creating a stack is easy, but the drawback is that the array must be declared to have some fixed size. So in case the stack is a very small one or it's a maximum size is known in advance. So then the array implementation of a stack gives an efficient implementation. But if the array size cannot be determined in advance, then we have to move to the other alternative method. So for that only we are using the linked representation. Okay, so if you know the size of the stack means we can go with the array implementation concept. So that is more efficient implementation. But you don't know in advance, you don't know the size of the size means size of the stack means what we can do, we can use the linked representation. So the storage requirement for the linked representation of the stack with the n element is big O of n, and the typical time required for the operation is big O of 1. So this is the space complexity, that is the space required, and this is the time required for the operation. So the linked stack. So every node has two parts. One that stores the data and another one is store the address of the next node. So it is same as what we have used in the linked list. So the node, it is divided into two parts. One contains the data or the information and another one contains the address of the next node. Okay. So here the starting position is a top. Okay, here start is a top. The start pointer of the linked list is used as a top, and all the insertion and deletions are done at the node pointed by the top. So here only we will do the insertion or a deletion. Suppose if the top is equal to null. Okay, suppose top is equal to null means it will indicate that the particular stack is empty. Okay, it will indicate that the stack is empty. Next we will see the push operation. So push operation is used to insert the element in the stack. Okay, so whenever you are going to do the push operation, the element will be inserted in the top position. Okay, the element will be inserted in the top position. So for example, if you are going to insert the element with the data insert the element 8. Okay, enter the element 8 means first we have to check top is equal to null. Okay, we have to check top is equal to null. So if it is equal to null means okay, the stack is empty and we are going to insert the first element. Okay, we are going to insert the first element. So what will happen? So this is the node with the data 8 and the address part will be null here. Okay, the next part will be null here. And if top is not equal to null, okay, if the top is not equal to null, okay, if the top is not equal to null, then what we will do, we will insert the element here. Okay, and we have to change the top position here, and the address will be this node's address. Okay, so this is the push operation. And next we will see about the code for the push operation. So this is the code for the push operation. Okay, so here we are declaring one pointer variable, that is ptr. Then by using the malloc function, we are allocating the memory space for the ptr. Then what we are doing, we are assigning the value for the new node's data part. So this is a new node, consider this is a new node, and I have taken the value as the 8. Okay, so the value 8 is stored here. Okay, then what we have to do is we have to check the condition top is equal to null. If this condition is true, okay, if top is equal to null condition is true means the particular stack is empty. So what will happen? So this is the new node with the data 8. So in the next part, so in the address part, it will be null, and this is the top node. And if this condition is false means it will go to the else part, and ptr tends to next is top. So here address part will be this top node's address. So top node's address, then what we are doing, top is equal to ptr. We are assigning this is the ptr node, right? New node is a ptr node, and we are assigning this node as a top. Okay, we are assigning this node as a top. So this is the method for doing the push operation. And next we are going to see about the algorithm and the code. So here first we have to allocate the memory space for the new node. Then here we have taken the new node variable as a new node, but here we have taken as a PTR. Okay, any variable you can consider. Then we are assigning new node tends to data is equal to value. So we are assigning the value here. Then we are checking the condition. If this condition is true means PTR tends to next is null. So here new node tends to next is null. Then top is equal to new node. Then if condition is false means we have to go to the else part. And here PTR tends to next is equal to top. Then top is equal to PTR. Then we are returning the top position. Okay, this is about the push operation. Next we will see about the pop operation. So it is used to delete the topmost element from the stack. Okay, it is used to delete the topmost from the stack. So before deleting the value, first we have to check top is equal to null. Okay, we have to check top is equal to null. So why we are checking this condition is, if the stack is empty, we doesn't require any delete operation. So we are checking this condition. And if this condition is true means it will print the message as the underflow. So that is the stack is already empty and there is no element to delete. Okay, there is no element to delete. Okay, and then we have to check if top is not equal to null. Okay, if the top is not equal to null means what we have to do in the top position. So this is the top position element, right? So the top position node will be removed. Okay, it is deleted, and what will happen, the next node will become as a top. Okay, top position means the top node is removed, and what will happen, the next node will become as a top. Okay, we will see the code. So this is the code for pop operation. Okay, so we are declaring one pointer variable, there is a PTR, and next what we are doing, we are assigning PTR is equal to top. So this is the top position and we are assigning this as a PTR. Then we are checking the top is equal to null. Okay, we are checking the condition top is equal to null. If it is null means it will print the messages stack underflow. Okay, it will print the messages stack underflow. And if it is false means what it will do, top is equal to top tends to next. Okay, top is equal to top tends to next. Now this is the top. Okay, this is a top. Then it will print the value being deleted is. So what is the value here? 1. Deleted is PTR. So it will print the value being deleted is, what is PTR tends to data, that is 1. Deleted is 1. And by using the free function, what we are doing, we are removing the particular node from the stack and it will return the top. Okay, so here what we are doing, we are assigning PTR is equal to top. So the top node is a PTR now. Then we are checking the condition. If the condition is true, nothing, no node is available means it will print the message as the stack underflow. If it is false means what will happen, we are making the next node as a top. Then the value being deleted is pointer tends to data. So this value is printed like this. Then we are removing the node by using the free function. So this is about the pop operation.